Hello everyone. In today's lecture, we will be seeing how to determine adequacy of rain gauge stations. Adequacy, or in a better language, we can say how to determine optimum number of rain gauges that can be provided in a particular area, ताकि जरूरत से ज्यादा रेन गेजेस प्रोवाइड करके हम अननेसेसरी एक्सपेंस ना करें और जरूरत से कम रेन गेजेस प्रोवाइड करके हम कोई इंपॉर्टेंट डेटा मिस आउट ना करें. दिस इज एन एग्जांपल ऑफ केरला स्टेट showing location of different rain gauge stations. Okay, so to better understand how to determine adequacy of rain gauge stations, we'll try to solve this numerical and see how this works. So this numerical says that there is a catchment which has 6 rain gauge stations, PQRSTU, and these are the annual rainfall values. That is साल भर का एवरेज यहाँ पर आपको हर स्टेशन का दिया हुआ है. हर स्टेशन पे रेन गेज लगाया और उस रेन गेज की जो डेली वैल्यूज हैं उससे एवरेज निकाल के साल भर का एवरेज निकालना है. और अब आपको दो पार्ट्स में क्वेश्चन पूछा गया है. यू हैव टू डिटरमाइन standard error in the estimation of mean rainfall, and in the second part you have been given 10% error and you have to determine the optimum number of rain gauges. Okay, now what is this error and what are they actually talking about? So the formula to determine optimum number of rain gauges is purely statistical based. Okay, when huge data sets are being studied, certain statistical parameters are computed, and based on that, this formula has been derived. Optimum number of rain gauges n is equal to CV upon epsilon whole square, where CV is the coefficient of variation. This is a statistical parameter, which we'll now see how to determine coefficient of variation. And epsilon is the error. So definitely whatever values we are getting are not the perfect values. We are using some other the technique to determine the values. So we also need to know what is the error that is being incurred when we are approximating or using our own techniques. Okay, so CV here is basically 100 into standard deviation upon average rainfall. Now, how do we determine standard deviation and see? Let us open up an Excel sheet for the same. Okay. We'll open up an Excel sheet and we'll see how these calculations are being done. So these are the different stations and these are the precipitation values obtained. Now, P bar or average precipitation is being computed here. Okay. Here, I will be computing average precipitation. This by using Excel, I have calculated average precipitation, which comes out to be 121. To determine standard deviation, what we'll do is we'll subtract each value from the average value and we'll square it. Okay. Now, since this cell is fixed, I'll be using a dollar sign here. Okay. This is how I'll be subtracting each precipitation value from average precipitation. This is P bar, okay, and this is Pi, okay. So Pi minus P bar whole square is represented here in this cell. Pi minus P bar whole square is represented in this cell. I'll just sum it up. When all these values are computed, I'll sum it up and I'll divide this by 5. Why did I divide this by 5? The formula for determination of standard deviation, when I want to determine standard deviation, that is the sigma m minus 1. The formula for sigma m minus 1 is under root of summation of Pi minus P bar whole square, that is each precipitation value minus average value whole square for each value. Then you sum it up and then you divide it by total number of data minus 1. So here we have 6 data, 6 rain gauge stations. So we'll just determine. We have computed this. Now square root of this value will give me my standard deviation. Okay, so standard deviation in this case is 38. To determine CV, the formula we have already seen, 100 into standard deviation upon average precipitation. 100 into standard deviation upon average precipitation, which comes out to be 31.5. So in our case, CV comes out to be 31.5. In the first part of the question, we have been asked to determine standard error. Okay. In the first part of the question, we have to determine standard error. We'll again write down this formula, n is equal to CV upon error whole square, wherein CV we have already computed as 31.5. N we already have as 6. So 6 equal to 31 upon 0.5 upon epsilon whole square, or epsilon would be 31.5 upon under root 6. Okay. We'll determine this upon SQRT 6. This comes out to be 12.82. So in our case, the error percentage is 12.82%, which was the first part of the question that was asked. Okay, so if we have 6 rain gauge stations, we have an error of 12.82%. Okay, now we want an error of 10%. So definitely the error needs to be reduced. So what is the optimum number of rain gauges? So here again we'll use the same formula. We only know of this formula. CV we already know is 31.5 and error permitted is only 10%. So 31.5 upon 10, that is 3.15 whole square. Okay, we can do it also on a calculator. So 3.15 whole square would be 9.92. 9.92, we'll round it off on the higher side. So 10. So the optimum number of rain gauges needed are 10. And we've been asked calculate the optimum number of rain gauges in the stations. So they are 10. 6 are already provided. So additional rain gauges required. Many a times additional rain gauges are asked and people normally stop at this. But additional rain gauges required are 4. 4 more rain gauges are required. Okay, this is how we calculate optimum number of rain gauges required. Now, what if rainfall data is missing from some of these rain gauge stations? This is what you are going to study in the next part. Stay tuned. Thank you for listening.